In this video, we're going to be doing the examples for the normal distribution. So this first example here says that given a standardized normal distribution with a mean of 0 and a standard deviation of 1, what is the probability that, and part A asks us that z is less than 1.57. First, what does this question actually mean? Well, the z is less than 1.57 says that our z-score is less than 1.57, and we want to know the percentage of your data points that are that have a z-score less than 1.57. Well, there's a table in your book called the cumulative probability table. It is on page 740, and it is table E2. So you look at that to try to determine this answer. So z is less than 1.57. You go along the left-hand side to get to 1.5, and then you move to the right until you get to 0.07, and that'll be 1.57. And if you look at that number, it says 0.9418. That means that 94.18% of the values have a z-score less than 1.57. If we continue along with this idea, let's look at part B. Part B says z is greater than 1.84. So we go along the table to 1.84 again, and we get 0.9671. But what does that represent? That represents the percentage, so 96.71%, of values of data points that has a z-score less than 1.84. Well, we want to know the percentage of values that has a z-score greater than 1.84, so we just take 1 minus 0.9671, which is 3.29%. Question C is, what about a z-score between 1.57 and 1.84? Well, if 1.57 has 94.18% below it, and 1.84 has 96.71% of data points below it, then between there is just 0.9761 minus 0.9418, which will give us 1.53%. And finally, for this question, what if we ask z is less than 1.57 or greater than 1.84? Well, that's just the complement of this region right here that we solved in C. So 1 minus the 1.53% should give us 98.47%. And we'll do one more example, but this will be related to a real-world problem. So suppose we have a study that indicates that 18 to 34-year-olds spend a mean time of 93 minutes watching videos on their smartphone each week. Assume that this amount of time watching videos is normally distributed and the standard deviation is 15 minutes. Well, what can we do with that information? When we ask this first question, what is the probability that a person in this age range spends less than 77 minutes watching videos on their phone each week? Well, how can we solve that? We have a table that relates our z-scores to this problem. So you should find the z-score of 77 minutes. Well, how do you do that? Our formula is z is equal to the x value that we're dealing with minus the mean divided by the standard deviation. Well, the x value we're dealing with is 77. The mean we were given in the problem, and that was 93. And the standard deviation we were also told in the problem, which was 15 minutes. Excuse me, I'll move the paper. There we go. So if we plug all that in, we get 77 minus 93 over 15, or in other words, negative 16/15, which is negative 1.06 repeating. Okay. Now, how might we deal with that? We don't have negative values on this table. We do have negative values on that table. I'm just kidding. That is on the previous page, 739. So if you go to negative 1.06, how do you find that? So we go to negative 1.0, and we go up to negative 1.06 here. It says, okay, found it. That says 0.1446. So we get 0.1446 or 14.46%. Okay. So what does that mean? That means 14.46% of the people in that age range, 18-34, spend less than 77 minutes watching videos on their phone each week. We're going to do a related problem, part B here. What is the probability that an 18 to 34-year-old spends between 77 minutes and 109 minutes? Well, the 77 minutes, we already found the z-score for that. That was negative 1.06. And the percentage related to that was 14.46%. So that came from the 77. We just did that in the previous problem. What about 109 minutes? Well, we do the same thing as before, except for our z now is 109 minus 93 over 15. This is 16 over 15, which is again approximately 1.06. So we go back to our table on page 740, and we look up what that value is. Almost there. 1.06, we go along 1.06, and we find that that is 0.8554. Oh, 0.54%. Now notice, that should actually make sense. What is 100% minus 14.46? Well, that is the 85.54%. Because the normal distribution is symmetric, if we have a z-score of negative 1.06, then the percentage below that is 14.46%. So if we have a z-score of positive 1.06, then the percentage above that should be 14.46%. In other words, the percentage below 1.06, positive 1.06, should be 85.54, or the complement of the 14.46%. So, now, if the actual question asks us to find the number of people in that age group that spend between 77 and 109 minutes on their phone each week, well, that's just 85.54 minus 14.46. And that'll be the percentage value. We're going to skip ahead and say, this is actually part D for this question. Part C is similar to the previous ones. Part D says 1% of all 18 to 34-year-olds will spend less than what number of minutes on their phone watching videos each week. Okay. Well, what is this? How do we do this? Well, 1% of all 18 to 34-year-olds will spend less than what number of minutes on their phone watching videos each week? we need to find the z-score related to 1%. So we go back to that page 739, and we look for when we get 1%. And it looks like we run into 1%. We run into 0.0099 at negative 2.33. So this is approximately, the z-score for this is approximately negative 2.33. Okay, and then we have a formula that tells us what the x value is that results in a particular z-score. And that formula was x is equal to mu plus z times sigma. So what is this then? X is equal to mu. Mu was our mean, which was 93, plus the z-score of negative 2.33 times the sigma. What is the sigma? Well, sigma was our standard deviation, which was 15. That was given in the problem. So was the mean. Okay, and then you plug that into a calculator, you find out what that value is, and that is the x value. So the number of minutes that 1% of all 18 to 34-year-olds will spend less than that amount of time watching videos on their phone each week. And that ends this section.